Simply put, the quantity theory of money is the idea that the supply of money in an economy determines the level of prices, and changes in the money supply result in proportional changes in prices. In other words, the quantity theory of money states that a given percentage change in the money supply results in an equivalent level of inflation or deflation. This concept is usually introduced via an equation relating money and prices to other economic variables, as shown by the following setup. In order to evaluate the quantity theory of money, we need to introduce what's called the quantity equation, which is what we have shown here. In this quantity equation, we have M, which represents the money supply. We've got V, which represents what's called the velocity of money, which is just on average how many times currency is exchanged for goods and services within a given period of time. You can think of this as how many times money changes hands on average. On the right-hand side of our equation, we have P, which is an aggregate or overall price level, and we have Y, which is the level of real aggregate output, usually being gross domestic product or GDP. So let's think about what's going on in this equation. On the right-hand side, we have the price level times the level of real aggregate output, which we can think of as just the total dollar value of everything produced in an economy within a given period of time. So we have total dollar value of output over here, and then over here we have the amount of currency available in an economy times how many times that currency changes hands, which makes sense because we have to have this currency paying for this output that we see over here. We call this form of the quantity equation the levels form because what it's doing is it's relating the level of the money supply to the level of prices. As an example, let's think about a very simple economy which produces 600 units of output and sells each of those 600 units for $40 each. We can see here that the total dollar value of output in this simple economy is just 40 times 600, or $24,000. So we need to have $24,000 available in order to pay for this output. If we look at the left-hand side of the equation, let's suppose that the money supply is $8,000. Well, if we have $8,000 in currency, then each unit of currency on average needs to change hands 3 times in order to pay for this $24,000 of output. At a fundamental level, this is exactly what this quantity equation says. In general, we can solve for any one of the 4 quantities given here as long as we know the value of the other 3 quantities. It just takes a little bit of algebra. We can see here that we could solve for M and say that the money supply is just price times output divided by velocity. We could solve for V and say that velocity is equal to price times output over the money supply. We could solve for P and say that the price level is equal to the money supply times velocity over output. Or we could solve for Y and say that output is equal to the money supply times velocity over the overall level of prices. The quantity equation can also be written in growth rates form, as seen here. As its name implies, the growth rates form of the quantity equation relates the percent changes in the money supply and the velocity of money to the percent changes or growth rates in the price level and in real output. As it turns out, the growth rates form of the quantity equation follows directly from the levels form that we originally started talking about. The reason for this is that if 2 quantities are always equal, then it stands to reason that the growth rates of those 2 quantities must also always be equal. So that gets us to, if MV equals PY, then the percent change in M times V has to equal the percent change in P times Y. Also, it turns out mathematically that the growth rate of 2 things multiplied together is just the sum of the growth rates of those individual things. So here we can say that the percent change in M times V is just the percent change in M plus the percent change in V. Similarly, we can say that the percent change in P times Y is just the percent change in P plus the percent change in Y. So it's pretty simple to go mathematically from the levels form to the growth rates form of the quantity equation. The quantity theory of money holds if the growth rate of the money supply is the same as the growth rate in prices, which will be true if there's no change in the velocity of money or in real output when the money supply changes. Historical evidence shows that the velocity of money is pretty constant over time, so it's reasonable to believe that changes in the velocity of money are in fact equal to zero. The effect of money on real output, however, is a bit less clear. Most economists agree that in the long run, the level of goods and services produced in an economy depends primarily on the factors of production, such as labor and capital, available and the level of technology present, rather than the amount of currency circulating, which implies that the money supply can't affect the real level of output in the long run, which would give us this zero here. When considering the short-run effects of a change in the money supply, economists are a little bit more divided on the issue. Some think that changes in the money supply are reflected solely in price changes rather quickly, and others believe that an economy will temporarily change real output in response to a change in the money supply. This is because economists either believe that the velocity of money is not constant in the short run, or that prices are sticky and don't immediately adjust to changes in the money supply. Based on this discussion, it seems reasonable to take the quantity theory of money, where a change in the money supply simply leads to a corresponding change in prices with no effect on other quantities, as a view of how the economy works in the long run, but it doesn't rule out the possibility that monetary policy can have real effects on an economy in the short run.